right, here we're going to talk about symmetry or symmetrical data versus skewed data. So what does that mean? Well, I think we've all heard the word symmetry, where the left side and the right side are equal, right? So you can see this one in the middle is symmetrical, where it's perfectly even, left and right side are the same. If it's symmetrical, that means the mean is the same as the median. So they are all right in the middle. This is the mean, this is the median. So if the mean and the median are the same, we have symmetrical data. Would you like to know how often that occurs? Yep, not very often. Okay, now, if it's skewed left, so skewed left, you can see how the tail goes to the left, right? If you have a tail going to the left, that means the mean is smaller. So the mean's on this side, and the median is over here. So I always think about the mean. The mean is in the tail. So if the tail goes to the left, the mean is to the left. That means the mean is less than the median. Now, if you're skewed to the right, that means the mean is larger. So the mean, right, it's got to be in the tail. So the mean's on the right if it's skewed right. And the median would be on the left. Okay? So I always start with the mean. If the mean is less, it's on the left. If the mean is greater, it's on the right. And that's how you know which way it's skewed. So let's do some math with this, shall we? Sure we shall. So, normally, we expect the elderly to die, but not the young. Since more elderly people die than the very young, is age at death skewed left or right? And I know what you're thinking. Wow, can we be any more depressing? I think the answer is probably yes. So I'm going to kind of just sketch a little graph about this because I think it's easier if you have a visual. So on the bottom here, we're going to have age at death. And here we're going to have the number of people dying. Right? So we'll have like 0, 20, 40, 60, 80. If you think about this, where are the majority of people dying, right? In their 60s, 70s, 80s, 90s, the 100s, right? The old people. So we talk about lots of these people are dying. So the bump would be really big over here. And not very many like 100-year-olds dying because they're just not around. But when you think about it, yeah, there are 40-year-olds, 20-year-olds, 0-year-olds. There are young people who die, but it goes lower, right? So this is where the tail is. So if the tail is to the left, then this is skewed left. Skewed left. Because the tail goes to the left, right? Kind of give yourself a little visual. All right, let's look at this. How are the ages of the Ivy Tech students distributed? Well, if you think about this as a curve, the tail is going to the right. Therefore, this is skewed right. And if it's skewed right, that means the mean is greater than the median. Because the mean will be in the tail, and if the mean is greater than the median, then it's skewed right. Okay, so let's do some math here, a little refresher on mean and median. Professor Ivy's students received the following grades on an exam. 0, 0, 55, 72, 75, 80, 80, and 85. I'm assuming these two suckers just didn't show up because really, how do you get a 0? Right? You can know nothing, get better than a 0. Okay, so first off, what is the mean of the students' scores? Well, recall that the mean, you add them all together and divide by how many there are. So when I add all of those together, I get 447, and there are 8 students, so I divide by 8. That means the mean is 55.9, or a 56%, which is an F. So by using the average, you can say, her students averaged an F on this exam. And that's really sad as a professor. You never want to say that. But you know what happens? Happens to all of us. Now, what's the median? Well, remember the median, they're already in order least to greatest. And I do the cross-off method. 1 on the bottom. Work my way in. 1 bottom, 1 top. Work my way in. 1 bottom, 1 top. I'm left with 2 numbers in the middle. So the median is going to lie right between them. So I take 72 plus 75, and I get 147. There are 2 numbers, so I divide by 2. I'm basically finding the average of those middle numbers. And I end up with 73.5, which is a C. Okay. Now, the 2 students who receive zeros are causing the data to be skewed. How is this data distributed? Well, remember that the mean is 55.9 and the median is 73.5. The mean is greater, oh my gosh, no it's not. Whoa. 55.9 is totally less than 73. It's not even close. It's not even late. I shouldn't even be tired. What's wrong with me? The mean is less than the median, and therefore we are skewed left. Now, which value, the mean or the median, is a better representative of the typical score on this exam? So you're looking at this. Would it make sense for this instructor to go around and be like, the average was a 59, or 55, my students, blah, 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 blah? No. I mean, look, only one student really scored a 55, and we had 2 zeros. Everybody else was up 72 or higher, which means the 73.5 makes more sense to talk about this as kind of a typical exam grade. Those 2 zeros really, really affect the mean in a negative way. That's not a good representative of the people who took your test, especially because those two probably didn't take it. They didn't show up. So it's just really not a good representation because they really bring down the average. So sometimes when you're trying to get a good representation of your data, the mean is not always good because the mean is very, very impacted by outliers or those extreme values of zeros. So pay attention to what data you have and what you're trying to find.